throughout the world. These standards and recommended practices are recorded in Annex 14 Aerodromes. For further information concerning these lighting aids, you are referred to this document. The simplest and most common aerodrome lighting consists of runway edge, threshold, and end lights. Runway edge lights are white lights spaced at 60-meter intervals along the sides of the runway. At the threshold, the beginning of the portion of the runway usable for landing, there is a transverse row of at least 6 green lights. These lights may be either equally spaced across the threshold or have a gap in the middle. As we begin an approach to a runway, the edge lights give some directional guidance for lining up the aircraft. As we near the runway, the changing perspective and apparent swinging out of the rows of lights substitute for seeing the actual runway and assist us to judge our height for landing. Runway edge, threshold, and end lights are basic to all aerodrome lighting systems. Alone, they are adequate only under good visibility conditions. In poor visibility conditions, they must be supplemented by approach lighting. When instrument approaches are made with relatively high visual ranges and decision heights, a simple approach lighting system is added to the basic runway lighting. A simple approach lighting system is a row of lights spaced at either 30-meter or 60-meter intervals along the extended center line of the runway and extending 420 meters into the approach. At 300 meters from the threshold, there is a crossbar of white lights. A variation of this system is to use barrettes for the center line instead of single lights. A barrette is 3 or more closely spaced lights that appear as a bar of lights. Here, in an actual approach situation, we see the approach center line lights with roll guidance information provided by the crossbar. This permits us to correct the alignment of the aircraft. When we pass over the crossbar, we know we will be 300 meters from the runway. As we near the runway, our attention shifts to the threshold and runway edge lights to complete the landing. Once again, the simple approach lighting system is adequate only in the better instrument conditions. When weather conditions are worse, a system providing greater visual guidance is required. These are called precision approach lighting systems. For Category 1 operations, a precision approach Category 1 lighting system is required. The lighting system may be one of 2 standard types shown here. In both systems, the center line lights are extended to 900 meters from the threshold. But the one system uses a row of single lights over the inner 300 meters, 2 lights over the center 300 meters, and 3 lights over the outer 300 meters. The lights are always spaced at 30-meter intervals. Also with this system, crossbars are located at 150 meters, 300 meters, 450 meters, 600 meters, and 750 meters. These crossbars may be of equal width or, as you see, vary in width so that they appear to point toward the runway center line 300 meters inside the threshold. More threshold lights are used with Category 1 systems. Either additional lights are added to the sides or the lights are extended completely across the threshold at 3-meter intervals. Now we shall see this system under actual conditions. As we approach the runway, we maneuver the aircraft to line up with the center line. When visibility is restricted, information from the center line lights tells us that we are in the outer 300 meters when 3 lights are visible, in the middle 300 meters when 2 lights are visible, and in the final 300 meters when only one light is to be seen in the center line. The other common standard precision approach lighting system used in Category 1 ILS conditions utilizes barrettes for the full length of the 900-meter center line and has only one crossbar at the 300-meter point before the threshold. In addition to the centerline barrettes, sequence flashing lights are often used. These extremely bright lights are timed to flash in such order that twice each second a ball of light appears to move down the center line toward the threshold. While we are still at a considerable distance from the aerodrome, the sequence flashing lights provide positive identification of the approach lights from other lights in the area. Precision approach Category 1 lighting systems are designed for operations down to a 60-meter decision height and an 800-meter runway visual range. To go below this, down to a 30-meter decision height and a 400-meter runway visual range, a Category 2 system is needed. The principal difference between the Category 1 and 2 approach lighting systems lies in the inner 300 meters. The outer 600 meters may be either of the two systems we just saw. Barrettes are always used for the inner 300 meters of the center line of the Category 2 system. Added to this are two side rows of red barrettes. A crossbar at 150 meters and a crossbar at 300 meters. For the threshold, the green lights are spaced at 3-meter intervals across the runway width. When a pilot is making an approach in Category 2 conditions, he may see only the inner 300 meters of the approach light system and then only a portion of it at any one time. This is why additional lights have been added in this area, since at this point only seconds are available to decide if a landing can be made. The red side rows give unmistakable information as to what part of the system we are looking at. They also help us to judge how far off the center line we may be, and thus decide if we can land or should go around. The red color differentiates the lights from those used on the runway for touchdown zone lights, so we will not think we are over the runway and land. The crossbar at 150 meters lets us know how close we are to the threshold. The system you see here is standard for all precision approach runways Category 2. For approaches in Category 2 conditions, two other types of lights are required: runway centerline lights and runway touchdown zone lights. Runway centerline lights are white lights. They extend along the full length of the runway and may be installed at intervals of either 7.5, 15, or 30 meters. These lights are also useful on takeoff in poor visibility conditions and may be provided separately just for this purpose. Runway touchdown zone lights are white barrettes extending over the first 900 meters of the runway after the threshold. The barrettes are located in rows on each side of the center line. Note that the gap between the rows is the same gap as used between the rows of red barrettes in the approach lighting. The longitudinal spacing of the barrettes is either 30 meters or 60 meters. Now we are making an approach using the Category 2 system. For Category 2 systems, the sequence flashing lights terminate at the 300-meter crossbar. As you see, on passing the green threshold, the red side row barrettes of the approach lighting change to the white touchdown zone barrettes. Centerline guidance is provided by the runway centerline lights, but they are single lights instead of the barrettes used for the approach center line. The combination of centerline and touchdown zone lights gives us greatly increased feeling for the runway surface. After touchdown, we roll on down the runway, soon passing the end of the 900 meters of touchdown zone lighting. Although there are edge lights, we would concentrate on the center line for guidance. Our next concern is locating a taxiway to get off the runway. Taxiway lighting can be divided into two categories: edge lighting and centerline lighting. Let's look at edge lighting first, as it is the most common type. They are blue lights, normally spaced at 60-meter intervals on both sides of the taxiway. On curves, the spacing is reduced so as to define the curve better. Taxiway centerline lighting may be used instead of edge lighting or in addition to it. To distinguish centerline lighting from edge lighting, green lights are used on the center line. There are some circumstances when centerline lighting is particularly needed. 1, on exit taxiways. 2, at complex intersections. And 3, for guidance when operations are planned in runway visual ranges below 400 meters. At the majority of aerodromes, centerline lights are only provided on exit taxiways and at complex intersections, with edge lights provided along the entire taxiway network. For runways where operations will be conducted below 400 meters RVR, the entire taxiway network should be equipped with taxiway centerline lights. Exit taxiway lighting is most important to understand, as you will be traveling at a higher speed on the runway, and time to recognize the exit will be short. Exit taxiways can be divided into two groups: slow-speed exits and high-speed exits. High-speed exits permit you to exit by making a large, curving turn from the runway. Green centerline lights are used on these exits. To give advanced warning of the approaching turn, the lights begin 60 meters in advance of the beginning of the turn-off point. The lights continue beyond the edge of the turn to a point where a normal taxiing speed would be reached. Slow-speed exits are those requiring about a 90-degree turn from the runway. Green centerline lights are used, starting near the runway centerline and continuing until you are approximately 30 meters off the runway. Now, we shall exit from a runway. The first turnoff is made on a right-angle taxiway, equipped with blue edge lights. Our next turnoff is onto a high-speed exit taxiway, also with green centerline lights. Another important visual aid is the VASIS, or Visual Approach Slope Indicator System. This aid provides approach slope guidance to the pilot by day or by night. The VASES consists of an upwind bar formed by two groupings of 3 light units, one grouping on each side of the runway, and a downwind bar, also having 3 light units on each side of the runway. The light units have highly directional light beams, which project a clear white light in their upper sector and a red light in their lower sector. The lights are precisely aligned with the approach to land slope, so that the colors visible to the pilot indicate his position with regard to the approach slope. A typical installation is shown at the left of the runway. When both upwind and downwind bars are white, the aircraft is too high. When both are red, the aircraft is too low. The correct slope is indicated when the upwind bar is red and the downwind bar is white. Let's fly an approach using the visual approach slope indicator system. As we pick up the VASES, we are on the proper approach slope. However, note, the lights of the downwind bar are turning red. We are now getting too low. So the aircraft is eased up. And we are back on the correct approach slope, with the near or downwind bar showing white light and the upwind bar red light. We are on slope, ready for landing. The design of most aerodrome lighting is for guidance in low visibility conditions. It is when visibility is restricted that the significance of each light becomes important. Standardization of position, intensity, and color become continually more critical as visual range and decision height are reduced.